In the quadratic program, we use decision structures to avoid taking the square root of a negative number, thus avoiding a runtime error. And this is true for many programs. Decision structures are used to protect against rare but possible errors. But sometimes programs get so many checks for special cases that the algorithm becomes hard to follow. So we can use exception handling to solve this design problem, and this approach obviates the need to do explicit checking at each step in the algorithm. And let's try this in the editor. And here's our first version of the quadratic program where the program could crash if this value is 0. And then here's our second version where we try to prevent the program from crashing with the if, elif, and else structure. But let's go back to this and save this program as, let's name it number 3. And this time we're going to use try and catch to prevent the errors. So one thing I want to do is, this is where we think the program may crash for the value error, but program could also crash here for input error. So let's put the entire block into the try and error, try and except. So I'm going to put this code in try, so the entire code here, that including this one. All right. Let's not forget our \n. I'll also put a \n here. Then we don't need this now. Okay, so we're going to try this, and if the program somehow fails here, like more specifically here, we can use the except block, and the type of error that we saw in this example was the value error. So we're gonna get a value error, and let's handle it. So the way we want to handle is, so here we said that if this scrim is less than 0, this equation has no real roots. So this is what we want to print out. Alright, so now we don't have to write an if and else to test this. If this try block works without any problem, we're just going to run this program, move on. However, if the program raised an error here or exception here, we know how to handle it and we'll move on. So I'm going to try this program now. So the version 3 quadratic.py. Okay, let's test 1, 2, 3. This equation has no real roots. That means that this program raised an exception, value error. We handle it this way. However, if your inputs are, say, 3, 4, and 1, it should work. Okay, so another one that could cause the program to crash is, let's say we're expecting 3 integers, right? Or not. Let me change this to int first. Okay, so let's rewrite this program. So I'm going to enter, say, 1.4. This equation has no real root, but it sounds like it also gave another error. So, but we don't know what error is this. Let's run this line of code with Python shell. So what would happen if I execute this program and enter 1.4? It is also another value error. So now they both are the same type of errors, so we can handle it with the same type of value error. But what I'm going to do is, I'm going to say value error as exe. So I'm going to assign a name. This is an object and this is a class. We don't know about objects and classes yet, but let's say what we can do is we can print the error message. Let's say print exe, and then I'm going to run this program again. So what happens if I enter 1.2? It says invalid literal for int with base 10 1.2, and what happens if we enter 132? Okay, I'm gonna try something that crashes. So 1, 2, and 3. This equation has no real roots. The type of error message we get is math domain error, and if we enter a value that is not integer, we'll get this error message. This is hard to write an if for, but I can use this one. I can say, make sure I copy it. I can say if exe is equal to this error, we can say, okay, this equation has no real roots. Okay, else we can say, okay, whatever that error message is. All right, so let's try one more time. Looks like we have one problem here. All right, so 1, 2, and 3, we get math domain error. The exact this get math domain error. Okay, what are we checking? We're checking. Okay, let's make sure that we check the string version of this str. Okay, one more time. It didn't work the way I expected. So 1, 2, and 3. So this equation has no real roots. Okay, now it works. And if I say 1.4, I'll get invalid literal for int with base 10 1.14.